So we're looking at some more special cases with one solution, many solutions, or no solution. Now, we have already looked at some of these. Okay, so what I want you to look at, this is how you pick out the information. Okay, so if it's going to be one solution, the final answer will result in something that looks like this. X equals, and A is just a number. So there will be one answer. There's only one real number that can make it true. Then, if it's infinitely many solutions or infinite solutions, you will get this right here. A equals A. And then last but not least, no solution will get A equals B, where A is a different number than B, and there's no possible answer. Now, this is the second time we're going through this. So we're going to look at this one right here. It already tells you that it's one solution. What I want to look at when we do this is first I'm going to distribute. I'm going to get 2x. I'm going to get minus 6 plus 9 equals 5 plus x minus 1. Combine like terms. I get 2x plus 3 equals x plus 4. So when I look at this right here, this is the stage I want to look at. The reason I want to look at that stage is because I want to compare it. Now I'm going to keep on going right now, but we're going to come back and I'm going to compare that stage. So I'm going to subtract x from both sides. I'm going to get x plus 3 equals 4. I'm going to subtract 3 from both sides, and I'm going to get x equals 1. Okay, so it has one solution. Okay, it has one solution. Now, I'm going to do this next one. This next one already tells me that it's infinitely many solutions. So we're going to look at this. I'm going to multiply through first. So I get 2x. I'm going to multiply here. I'm going to get plus 20 minus 17 equals 2x plus 3. Combine like terms over here, and I get 2x plus 3. Okay, we're going to look at this stage in just a second. I'm going to subtract the 2x from both sides, and I get 3 equals 3. So that's infinite many solutions. Then last but certainly not least, I'll do green, is this next one. And we already know it's going to be no solution. So I'm going to combine my like terms. So I get 2x plus 3. We're going to distribute here and get 2x plus 6 minus 5. So I get 2x plus 3 equals 2x plus 1. And we're going to look at this stage right here. I'm going to subtract 2x from both sides, and I'm going to get 3 equals 1. And 3 never equals 1, so this is no solution. Okay, so what I want to do is I want to look at those stages that have this stage right here, this stage right here, and this stage right here. Okay? If I do that, if I look at this, I'm actually going to write in hot pink. Okay, if I look at this highlighted stage here, okay, and I look on both sides of the equal sign, the coefficients are different. Okay, if I look at this, we have a 2 and we have a 1. This 2 and this one is invisible, and the constants are different. Now this part right here, the constants being different, this one's not as important. But this one right here, super important for you to understand that if it is a one solution, if it's one solution, the coefficients are going to be different. Then the next one we're going to look at is infinitely many solutions. If I look at this, look at my coefficients. My coefficients, that means this right here and this right here, they're the same. Then I'm going to look at my constants. Okay, this constant and this constant. They're exactly the same. That is how you're going to tell that it's infinitely many solutions. Then last but not least, I'm going to look over here at no solution. I'm going to look at my coefficient. Coefficients. If I look at this coefficient and this coefficient, they are the same. Then I'm going to look at my constants. Okay, 3 and 1. They're different. So, when I get to the stage where I have variables on both sides of the equal sign and everything is in simplest form, all I have to do is look at my coefficients and my constants to figure out which one is going to have one solution, which one's going to have infinitely many, and which one is going to have no solution. So let's go ahead and look at this. So if I have this one right here, I'm not even going, it says determine if each equation has one solution, many solutions, or no. If it has a solution, you figure out what that solution is. Okay, so first things first. Combine like terms. Look at this. Let's look at our coefficients. I'm actually going to change my color. I look at my coefficients. I look at this right here. Are my coefficients the same? My coefficients, they are the same. My constants are the same. They're the same. So if both of those are the same, that means that this is infinitely many solutions. That means it has so many solutions. It means that any number you plug in will work for this equation. Okay, so let's try it again. Let's look at this next one. Okay, so I'm going to multiply this through. I get 3x minus 3 equals 2x plus 9. Okay, let's look at the coefficients. Okay, if I'm going to look at this coefficient and this coefficient, they are different. That means that there's one solution to this. And because there's one solution to this, that means we actually have to solve this equation. That means there's one solution, and we have to figure out what that one solution is. So I'm going to subtract my 2x to the other side. I'm going to get x minus 3 equals 9. I'm going to add 3 to both sides and get x equals 12. So there is one solution, and that one solution is x equals 12. Next equation. So here we go. So we're going to distribute through. I get 4x. I get 12. Minus 4. Half of 8 is 4. And then 8 times 1. So I combine like terms. So I'm going to look at my coefficients. They are the same. I'm going to look at my constants. My constants are the same. So this is infinitely, helps if you spell right. Infinitely many solutions. Okay, so we're now going to go to number 4, and we're going to multiply here. If I multiply here, that's over 1. It's 3 over 2 times 2 over 1. This is going to get 6 over 2, which is 3. So this gives me 3x plus, and then if I take 6 and I multiply it by 3 over 2, that gets me 18 over 2, which is 9. So plus 9 equals 3x plus 9. Look at that. My coefficients are the same. My constants are the same. So this is infinitely many solutions. Okay, so number 5. Combine like terms. So I'm going to have 3 over 2x plus 7 equals, oh, look at this. I need to put this over 2. Okay, I'm going to come off to the side. So I can't believe I just did that. It's over 1 right now. I need to make it over 2, so I'm going to multiply by 2. So it's going to get me 8 over 2x minus 5 over 2x. When I subtract that, that'll get 3 over 2x. So I look at this. My coefficients are the same. My constant, oh, look at this. My constants are different. So that means that this is no solution. There is no answer that you can plug in that is going to get the correct answer. Okay? So 20 minus 5x equals negative 5x plus 20. Okay, so I can rewrite this like this. It's exactly the same on both sides of the equal sign. So that means this is infinitely many solutions. Here I would get negative 20 plus 5x equals negative 5x plus 20. Look at these coefficients, guys. This has a positive 5. This is a negative 5. So those coefficients are different, so that is one solution. This one would get me 25 minus 5x equals negative 5x plus 20. So the coefficients, those are exactly the same, but the constants are different. So that means that this is no solution.